Well, we've got a fun topic for you tonight. We're going to cover two things. We're going to cover inverses and average rate of change. So what is it that you need to know about inverses? Well, first, inverses are reflections over the line y equals x. Second, to find an inverse, you simply switch the x and the y, but then make sure you solve for y. Third, if something is just a function, we should know that it has to pass the horizontal line test. However, in our fourth note here, if a function has an inverse, then it must pass the horizontal line test. Now, maybe most importantly, we need to recognize the notation for inverse. And that notation is f and that -1. Okay, and again, in English, let's put it down, it's read f inverse. All right, so we'll start with some pretty easy ones and work our way up to definitely a hideous one we're going to see on the grizzly. So starting with A, I have the point MB. So remember, this is like my x and my y. And inverse literally means switch the x and y, so the inverse would be B comma M. Okay, we'll make it a little more challenging. This is a linear function, y equals 2/5 x minus 7. So we're going to go ahead and find its inverse by switching that x and y. And now we're going to go ahead and solve for y. So hopefully your gut's saying add over that 7. So I've got x plus 7 equals 2/5 y. Now, there's lots of options here. Maybe your gut's saying divide over the 2/5, but dividing by fractions is pretty darn ugly. So there's another method, and that's just multiplying by the reciprocal. So the reciprocal of 2 over 5 is just 5 over 2. And whatever I do to this side, I have to wrap up and also do to the opposite side. Now the whole point is I'm going to get a 10 over 10, which cancels, and that's why we do that. So I just get y. And I'm going to distribute here. I'm going to put this over 1. So I'm going to say that's 5/2 times x plus 35 over 2. And now I have found the inverse. So remind yourself, when you multiply fractions, you do the tops and you do the bottoms. Okay, getting slightly more challenging, we're going to switch that x and y. So I've got x equals the cubed root of y minus 6. So my goal, just like in any radical equation, is to isolate that first. So I'm going to add over that 6. And then I said, okay, how do I get rid of a cubed root? Well, your gut probably knows to get rid of a square root, you square it. So to get rid of a cubed root, you've just got it, you cube it. So whatever I do to that side, wrap up and do the same to the other side. So now those cancel, and I get y equals x plus 6 to the 3rd power. D, again, find the inverse. So I'm going to switch that x and y. Now notice the 6 is outside. Okay, so again, I have to isolate this term. So I'm going to subtract that 6 over first. So I've got x minus 6 equals the 5th root of y minus 4. Now, just like a cubed root or a square root, we did its inverse. We're going to do the inverse of the 5th root, which is raising each side to the 5th. So we'll zap out, and I've got x minus 6 to the 5th equals y minus 4. One last step to add that over, so I would say y equals x minus 6 to the 5th plus 4. And again, this is my symbol for inverse, or my notation for inverse. Okay, so you've guessed it. We've made it to the ugliest type of inverse that you'll probably come across. So the first thing we want to do, just like in every other problem, switch the x and y. The catch here is that there are 2 x's, so I'm going to have 2 y's in this problem. Okay, now basically, pretty much my gut is only saying that I should probably, cross multiply. I'm going to put this over 1 and cross multiply. So 1 times y minus 5 is just y minus 5. And then I'm going to have x times y minus 3. Okay, so again, I'm just going to continue to do what my gut says, distribute. So y minus 5 equals x times y minus 3x. Now remember, your goal is to solve for y. Do you see that there's 2 y's? You have to get those on one side and everybody else to the other. So I'm going to leave this y, and I'm going to subtract the xy from both sides. Got y minus xy. I'm going to leave this negative 3x, and I'm going to add this 5 over to this side. I've got plus 5. So again, all I did is I put the y terms on one side together and everybody else on the other. Now, I can't put these together because they're not like terms. This is one y and this is an xy. But I can pull out, and here's the key, a GCF. Okay, and I can pull out a y. Now, notice there's two terms. You have to have two terms still. Y divided by y is the number 1. And xy divided by y is x. How do you know if you pulled out the GCF correctly, guys? Well, it's simple. Just take this y and distribute it back. Did you get what you started with? Y times 1 is y times xy is xy. You did it. And we'll leave this side. And then lastly, I'm just going to divide by this quantity, 1 minus x. So I'm going to say y equals negative 3x plus 5 all over 1 minus x. Now, kind of a little trick for the trade here. If that's not the choice, and this is multiple choice, I want to remind you that this is equivalent to changing all the signs. So instead of saying negative 3x, you could have positive 3x minus 5 all over negative 1 plus x. Okay, so why is that the case? Well, would you agree 4/5 is the same thing as negative 4 over negative 5? As long as I change both of these signs, it's going to reduce back to the original. And that's what's happening here. So just be familiar, if your choice isn't there, try negating, changing the signs of all your terms. Okay, in this example, we're asked to graph log base 3 of x minus 2 and its inverse. Now, I can't stress enough, if you have the log base button, this is very easily done. For another reminder, you can find it under math. Again, I would be making a note to myself on my own paper so you can find it. You can find it in the catalog, which is second 0, and you can find it on the top row, which is alpha, and obviously one of those buttons on the top row. Okay, now, if you have that old TI-83, you have to use change of base. Okay, so again, change of base on the old TI-83 calculator. The only way you can type these in is to rewrite the base on the bottom. Remember, base goes on the bottom. So this is log, the little base is 3, so that goes on the bottom, and the x minus 2 goes on top. So make sure you know how to use, your calculator, I guess is my point. So however you're typing that in, now I guess one of our big downfalls this year is, for some reason, even though they're giving us a table, for the most part, we've been really bad at graphing these still. So I can't stress enough, what do you have to know about a log? Every log has an asymptote. That's part of the graph. You have to be able to find that. So I'm going to plot some points that I know. I know 3, 0 is a point. I know 5, 1 is a point. Okay, and I know a log graph goes this way. Now, it just doesn't stop there. There's an asymptote. Okay, so one hint is where this function doesn't exist. Okay, and remember, you can't take the log of 0. So I know at 2, minus 2 gives me 0, which means my asymptote is at 2. This might also help you out by just, verifying to yourself at 2, you notice that's where that first error occurs, and if I plug 2 in, 2 minus 2 is 0. Therefore, you can't take the log of 0, which means you should have a vertical asymptote. Okay, and again, this graph doesn't stop there. It goes closer and closer to the asymptote. Okay, now whether or not your calculator screen shows you the whole thing, that's one thing, but you have to understand that there is a vertical asymptote and that graph goes in both directions. Now it also says graph its inverse. So again, I'm just going to take the points that I know and flip them. So 5, 1 is now 1, 5. And 3, 0 is now 0. Oh goodness, I plotted that 5, 1 in the wrong spot. This should be 1, 5. I apologize. Over here. Let's see if I can undo that. Yep. Okay, so there's my 1, 5. And then 0, 3. 1, 2, 3 is this way. Okay, now I can find this equation by hand, or like I said, I can just switch the x and y's. So I am going to find this inverse by hand as a good reminder. It's been a long time since we've done this, because I only know those 2 points currently. So there's my equation. I'm going to switch my x's and y, so that's log base 3 of y minus 2 equals x. And then the whole idea was you had to convert to exponentials. Like I said, it's been a long time since we've done this. Maybe expect to see this on a quiz. We're going to convert to exponential. We said begin with the base, and we're going to go around and back in because a log is really an exponent. So 3 to the x equals y minus 2. Therefore, y equals 3 to the x plus 2. Okay, and that's what I would graph. So I'm going to get that table and go ahead and plot those points. So since this is exponential, it's basically just shifted up 2. I know my asymptote is going to be right here at y equals 2, and that my function should get close to this one and close to this one. And remember, they should be reflections since they're inverses over that line, y equals x. I should be able to fold it right in half and they should line up with each other. Okay, our second big topic tonight is average rate of change, and after we took our first big grizzly there, we noticed this was on a lot of questions, f of b minus f of a over b minus a. Okay, and remember, average rate of change is really just another way to find the slope. Okay, and you've been doing this since 9th grade. This is just the slope formula, y2 minus y1 over x2 minus x1. It's the same thing. Okay, we're just using function notation. All right, so our next goal here is to compare the average rate of change of each function. Okay, so because this function is called m, instead of saying f of b minus f of a over b minus a, I'm going to use m. m of b minus m of a all over b minus a. Okay, now they're going to give you 2 points to use. Let's say we say between x equals 4 and x equals 5. Okay, so I'm basically now going to say that's m of 5 minus m of 4 all over 5 minus 4. Okay, so my denominator is real simple. That's just a 1. Okay, now I have to get my m of 5. So I'm just going to go to 5 on the x and look at the height of m, and m has a corresponding height of 7. Minus m of 4, so I'm going to go 4 on the x, look up and find the function, and it has a corresponding height of 4. So I'm going to say it has an average rate of change of 3. And if we go ahead and plot those points, we're basically saying the slope from 4 to 5, if I draw it in, that should have a slope of 3. Okay, we're going to do the same thing with p of x. So instead of giving a graph, they're just going to give you 2 points. So again, this is my a and this is my b. So I'm going to say p of b minus p of a all over b minus a. Okay, so my p of b is negative 7, the y value, minus the y value here. So watch my negatives, a negative 3, all over negative 2 minus 4. So I'm going to put those together, and I'm going to say that's negative 4 over negative 6, which obviously reduces to a positive 4/6 or a positive 2/3. Lastly, I'm going to compare average rate of change on a table. And I'm going to say from x equals 4 to x equals 5 again. Okay, so this one's titled h of x, so I'm just going to do the same idea. So h of 5 minus h of 4 all over 5 minus 4. Okay, now I'm going to go a little further here. H of 5, so that's the y value at 5, and I'm going to put my units on as well. I'm going to say that's 14 feet minus h of 4 is 32 feet all over 5 minus 4 seconds. And I'm going to say that gets me a negative 18, and when I pay attention to my units, which is a big deal, that's feet per second. So this is changing at a rate of 18 feet per second. Well, I think that does it for us. We've got a big review on inverses as our real main topic, and we snuck that average rate of change in there. We'll see you tomorrow. Have a great night.